Liquid molecules, they move continually, and the particles are arranged based on their intermolecular forces. And some of the properties that happen with liquids are surface tension. That's what, as you saw in the crash course video, that's what allows liquids to kind of pile up on top. And when you overfill a graduated cylinder, it's what causes water droplets to pull themselves together. It's surface tension. It's the attraction of the molecules to themselves. There's also viscosity, which is resistance to flow. And the stronger your intermolecular forces and the larger the molecules, larger molecules would, among other things, have greater dispersion forces. Also, they can physically get tangled up with each other, but dispersion forces become quite significant at this point. The greater the viscosity. So, for instance, something like honey has a lot stronger intermolecular forces than water. And water has a lot stronger intermolecular forces than acetone. If you ever try to pour acetone or nail polish remover, it just kind of goes everywhere, as opposed to water, which kind of stays in a nice stream as you're pouring it. Now, solids and liquids do have similar volumes whenever you're comparing them. We saw yesterday how with water, it's a notable exception that when it forms that solid, it locks together with this rigid hydrogen-bonded hexagonal structure, which is also what gives snowflakes their 6 sides. And there's space in between them. And whenever you melt ice and turn it into water, you disrupt some of those hydrogen bonds. That's what that energy you're putting in to make it melt does, is it overcomes some of those hydrogen bonding interactions to turn it into a liquid where that rigid crystalline structure with those hexagonal holes in the middle of it kind of collapses. And it actually shrinks a little bit. But the volumes are relatively similar, especially compared to gases. And the particles in both are always in close contact with each other. Now this kind of shows a little bit about surface tension, how you can see the particles even on the surface are attracted to the other ones around it. And this shows glycerol or glycerin, which is very thick liquid. It can form hydrogen bonding in 3 different locations, plus it's got some pretty significant dispersion forces, and so glycerin has a much higher viscosity than water does.